now need to do is introduce you to Frank, Dr. Frank Ince, who's our speaker this evening. Frank is a retired organic chemist who used to work for AstraZeneca. And I guess that it's an organization, a company that we're all very familiar with. AstraZeneca has been in the news for the last 18 months, almost continually. But Frank told me that he worked in another area as an organic chemist during his time. But Frank may be better known to many of you, are also members of the Russell Society. Now, again, for those of you who don't know, the Russell Society is the National Society of Amateur and Professional Mineralogists that encourages the study, recording and conservation of mineralogical sites, materials and minerals. And the society is named in honour of Sir Arthur Russell, the foremost British mineral collector of the 20th century. Activities of the Russell Society include field trips, meetings, social events, and high quality publications. Frank is the Russell Society's journal manager. And Frank is here tonight to talk to us about the minerals of the China clay pits of southwest England. Over to you, Frank. Can you share your screen?
Yep, will do. Right, well, thanks for the opportunity to give you a chat about some aspects of southwest England. I'll explain as I go through that I've been there a number of times over the years, and it's changed quite a lot. So I guess the first view that I remember of seeing of southwest England, particularly the China clay pits, is what's known as the Cornish Alps. You can see them as you come off Bodmin Moor, and this was probably the best picture I could find, which represents what they look like, taken looking south over St Denis into the St Austell region. And they're obviously related. China clay pits are related to the granites, which are the pink blobs on here. We'll go through the geology later so that it all comes into context. And all of these areas of the granites have got China clay pits in. I guess most of us know the St Austell area best. Hopefully you can see my pointer. And it may come as a bit of a surprise, or it did to me when I first understood it, that in fact, in the history of China clay working, it's Tregonning Hill, which is just between St Pennance and Hingston. And it was down to this man, William Cookworthy. He was a pharmacist and a Quaker minister, and he spent quite a lot of time looking for interesting things in southwest England. Now, this is Tregonning Hill as seen by Google Earth, and this is the main road that goes from Hingston to Pennance, so it's just north, and it's this brown area. And you can see there are various holes in the ground around there. Well, one of those is this one, which is Cookworthy Quarry. And I assume, and I haven't got any real evidence for it, this is named for William Cookworthy, and may well have been where he first discovered his kaolinite. Well, he discovered it in 1746, but it wasn't until, oh, actually, excuse me, I forgot about this one. There is a memorial to him on the hill. It was put up in the 300th anniversary of his it's a bit out of focus, but this is the anniversary of his birth, and discovered it here. And we'll go on to talk a little bit more about all the things that are down below. As I was saying, he discovered it in 1746, but it wasn't until 20 years later, after a lot of experimentation, that he filed a patent and was granted a patent, and he exploited this at his Plymouth porcelain factory. Now, for reasons that I don't thoroughly understand, the Plymouth porcelain produced a number of things which are in the British Museum. Here we have a porcelain coffee can, as they call it, but it looks like a mug to me. And the date on the bottom is quite significant because it was 3 days before the date of Cookworthy's patent, and it seems to commemorate the first day of his firing, or the date of his first firing. CF may be Cookworthy Fechet, but may also be Charles Fox, who was one of his backers in Plymouth. They also produced some rather nice coloured ware. This is a nice mug, and the mark on the bottom here is quite interesting. It looks like a curly 4. Indeed, that's what it is, but it's actually the alchemical symbol for tin, and that was the Plymouth factory mark. He was at it for 2 years, and then the factory closed and his patent was bought by Richard Champion, who was then in Bristol. And after a little while, it was finally bought by New Hall Porcelain in Staffordshire, which, as most of you remember, was no, it's not called the Potteries around there for nothing. And indeed, the other people had got in on the act, Josiah Wedgwood here, and he, with John Carthew, a local landowner, had formed the Cornish Clay Company, and they were actually working China clay north of St Austell, and that was at the Trevisco pit, and we'll see that on a map of the area later. By the mid-1800s, there were 92 pits, and they were exporting quite a lot of China clay around the world at that time, mainly to this country and Europe, but elsewhere as well. As time went on, they were trying to improve the methods of extracting the China clay, and they were using fire hoses to wash it out of the crevices in the rock. By the early 1900s, they were using what are known as high pressure monitors, and they were getting down so deep that they were using explosives, and some of the workings are quite deep. Now, I know this is a modern picture taken from the Wheal Martin Museum in the 1980s, but it gives you some indication of the depth of these things. And you'll notice this little blob down here. And when you look at it carefully, not that particular one, but elsewhere in the Goonbarrow pit, this was in 1985, it's one of these, and this is the high pressure monitor. And after blasting, you end up with a blast pile, and then they spray this water on at really high pressure in it. And as I was there taking a photograph, it really makes quite a lot of noise. And as you can see, they fire it onto the blast pile. Quite a lot of this black rock is tourmalinized granite, which is naturally black. Granite is the grey stuff. And these hoses are quite powerful, blowing sort of dustbin-sized rocks up into the air. So we're actually quite away from it for safety reasons. Not that being hit on the head by a dustbin-sized lump of granite would actually be much good with the safety helmet on. By the 1980s and 90s, they were exporting an enormous amount, and again, quite a lot of this went to Europe. I think from the records, this is the high point, and there were 18 large working pits with over 200 abandoned ones across the county and in Devon as well. More recent figures show a slight reduction in production of China clay, and certainly a reduction in the number of pits down to 10. And still, in 2018, there were 60 million tonnes of China clay estimated to be 50 years of reserves. So what is all this China clay used for? Well, it's obviously in ceramics and porcelain, as we've seen, with a whole host of other sanitary ware, pipes and such ovenware, insulators. It's used as a filler in all sorts of places, and as used in pharmaceuticals as well. Some of you may actually have had kaolin and morphine when you've had an upset tummy. The other mineral products that you get from the China clay pits, and I'm excluding here the tin and copper mines to a large extent. Tin ore, which is cassiterite, tin oxide, tungsten ore, which is wolframite, which is a mixed metal tungstate. Some of it's iron and some of it's manganese. And more recently, there's obviously a world shortage of lithium, lithium batteries. And as we'll see, there are quite a lot of lithium-containing minerals, and also the lithium-rich brines from some of the copper and tin mines are being used. So we now have in our hands the latest investment opportunity. And I put it in brackets because Cornwall has been a sink for vast amounts of money from people who've been prospecting in all sorts of different ways in what's in the ground in Cornwall. And I think it's fair to say that a fair proportion of them lost their money. So if we come on to the geology of southwest England, all of these granites here are the same ones that produce the China clay. They were intruded in the late, between 274 and 300 million years ago, and that's in the late Carboniferous, early Permian, in the Vriscan orogeny, when Europe was again bumping into what was then England and Scotland. Now it looks as if all of these granites are coeval, but in fact they're not. There are at least two different major times when these were being produced. So we've got the Isles of Scilly, Bodmin Moor going forward in time, and then to, going backward in time, beg your pardon. And then one of the earliest events was a little bit on the edge of Dartmoor. We'll come to that a little bit later when we talk about minerals. So these are the relatively old components, and then there are a number of younger ones. They're all relatively closely spaced. They're not, well, they are millions of years apart, but, so they range from 285 in Dartmoor, main part of Dartmoor, down to 274 for West Penwith and the granite of Land's End. There is also an isolated undersea exposure of granite out in the Bristol Channel or the Western Approaches, called Hague Fray, and unfortunately I've not been able to find a date for that. Some of you may remember the Lundy granite. It's not related to that because that's about 60 million years old, so that's much, much, much younger. So again, get back to a larger scale map of the Cornubian batholith. As I say, it's intruded into older rocks, and although it's a bit difficult to read, the grey and the pinky grey rocks into which the granites are emplaced are Devonian and then running into Carboniferous. And this is the Crediton Trough, which is more or less a syncline, so that the older rocks appear on either side of it. So if we get back to where the China clay pits are, all of these granites, as I said earlier, contain literary exposures of China clay. There are just one or two where there's a little bit of doubt about what I've been able to find out. We're going to have a look at the St Austell granite because it's probably the most well studied from the point of view of the geology of all of this. Now, even the St Austell granite is not one single lump of granite. There are a number of different components to the rocks that are exposed around the St Austell granite, working from the outside inwards. In common with most igneous intrusions, it has a metamorphic aureole, and it's quite wide in some cases, presumably associated with the depth of the granite, not necessarily the strength of the metamorphism, but you can see the scale here is 5 kilometres. So it's at the minimum, it's sort of a kilometre, half a kilometre wide. And that has baked the country rocks and changed their character from sedimentary rocks to various sorts of metamorphic rocks. And we'll see one of those later. On either end, the stripy, vertical stripy rocks is a biotite granite, biotite being a form of mica. There's a small area in the middle here that's labelled as lithium mica granite, which is different in chemical structure from biotite, and obviously contains lithium, as it suggests. Then there's a tourmalinized granite in the diagonal hatching, which contains tourmaline, a rather complex aluminium, iron, magnesium, etc. Lithium as well, containing aluminous silicate, but it also contains boron, and we'll come back to that later. And then there's a tourmalinized granite, which is largely tourmaline rather than other associates. And then a couple of areas where there is topaz granite, and whilst they're difficult to photograph, they are there as a ground mass for some of the samples that I'll show you later. Just have a look at Luxulyan. You may have heard of Luxulyan, and one reason why you may have heard of it is because of this stuff. This is quite a large specimen, not quite a metre across, obviously, but it's actually destined to be a garden table as far as I'm concerned. It's in the middle of being polished, and I'm just about to, when the winter time comes, I'm about to get down to actually polishing this before making a stand for it. It's got very large orthoclase crystals embedded in a matrix of tourmaline and quartz, which gives us this rather characteristic structure. And you can see the various shapes of the orthoclase crystals. They basically look like matchboxes generally, but sometimes with ends that come to a pyramid. It's a very interesting rock to look at under the petrological microscope. This is some of the orthoclase, and these long needles are the tourmaline, and the ground mass here that is largely grey is actually quartz. So these are all growing in to each other. As I said, from a geochemical point of view, the granites are lithium and fluorine enriched. It's intruded during the Variscan orogeny, and it's 280 and a bit million years old. It's undergone several phases of hydrothermal alteration. Obviously, it was emplaced as a liquid or as a very viscous fluid at high pressure. And over time, as it cooled down, a whole variety of different chemical sequences of events took place. First one, which is relatively high temperature, is the boron-enriched tourmalinization, so the incorporation of boron into the fluids and then the crystallization of tourmaline. Then the various metalliferous veins going from relatively high temperature ones, which are tin and tungsten, through to various lower temperature ones, copper, and eventually down to lead in the form of galena, and various antimony minerals at a much lower temperature. And the kaolinization was after most of these mineral veins, and it's the alteration of the feldspars, which we saw in the Luxulyanite, which take the form of orthoclase there, but it can be microcline and albite, and that is chemically altered to kaolinite, and that usually happens at 100 degrees plus or minus a few. To say it, we've taken a case of orthoclase here, which is a potassium feldspar, potassium aluminium silicate, and it's converted to the aluminosilicate. This is the chemical reaction. So two of these reacts with some water with some acid in it, and it gives the kaolinite plus the potassium and some silica in solution. The interest of that will become apparent in a moment. At the same temperature, roughly, feldspar is is altered to muscovite. And it's this particular reaction, and this is a chemical formula that will suit us for muscovite at the moment, and more silica. So we've got two different reactions, two of which produce silica, one of which produces mica. And we've already got kaolin, which in its pure form is white. So it's no real surprise that when you look into a China clay pit, this is what it looks like. It's white. There's loads of kaolinite there, loads of mica, which if it's not altered much will reflect as white, and the quartz, which will enhance the white anyway. Now, the interesting thing about this picture is that, I mean, this is quite deep. I suspect this is much deeper than the 200 meters that I mentioned in the earlier discussion. And this little thing down here is actually one of these. Oh, no, we've had that. That was one of the monitors. Pardon, going back in my talk again. So we've got a number of China clay pits now, and at one time the whole of Cornwall would have looked, certainly the St Austell granite would have looked like this, and I certainly remember that sort of picture when I was coming down off Bodmin Moor when we went on our holidays in the 1950s. So what about the China clay pits themselves? We'll go gradually up country here and survey them both from a point of view of their what they look like now and what they've got in them as far as minerals are concerned. So the first one we're going to look at is in the far west, West Penwith, and there are three minor clay pits in the St Just area, and they're shown on this Google Earth picture. And this is one of the minor roads that goes from Pennance to St Just. These three, they're obviously all just holes in the ground now, although there's obviously evidence of working here. And indeed, there's a picture in the Royal Cornwall Museum in Truro, painted by Henry Harvey, which shows the Leswidden pit. Now, I guess that's what all of the China clay pits in Cornwall and Devon have gone through a phase that's not dissimilar to this, a large conical hill with a ramp going up it, with all the spare quartz and mica going over here and elsewhere on the site, kaolin being prepared as China clay for export. In terms of the minerals, there's a well-known site to mineralogists called Mindat, and if you put in any name of a mineral locality into Mindat, it will come up with a list of those minerals that have been found or reported to have been found there. And this is a list for lower boss strays, but the only picture I could find was of this. This is a tourmaline crystal, so it has this rather complicated structure. And all depending on the arrangement of and the number of elements here, these are sodium and iron, but if there was lithium in here, it would probably have a different name. It's called Shawl, this one, because it's traditionally a very dark green, brown, or even black, as this one looks. At Belowda, there's a much greater list of minerals. Obviously, kaolinites amongst them, but this specimen has got one of the associates that's not uncommon in the China clay pits, and that's siderite, which is tin oxide. And that's the basis of the tin industry in Cornwall. And the white stuff is mainly quartz, and some of this dark peripheral material here is more of the tourmaline variety Shaw. We saw the formula of that a moment ago. Unfortunately, I don't know what the scale of this one is. And this is actually an interesting specimen from Leswidden. It's the only mineral of any consequence is the black fibrous-y looking needles inside this cavity, which, as you can see, is vaguely hexagonal. And it's Shawl, probably because of its color and its form. But the interesting thing about the shape of the cavity is that it's actually roughly the shape of an orthoclase crystal. So the assumption with this is that there was an orthoclase crystal in here, and it's been chemically removed, basically. And what's left behind is the tourmaline that has crystallized either before the feldspar or after the feldspar was taken away by chemical activity. Now, we mentioned Tregonning Hill before, underneath the blue star there. And you will have noticed, no doubt, that there were two other holes, two of them, Wheal Grey and Wheal Tressails and Cookworthy Quarry, which we mentioned before. This is a picture of Wheal Grey as it is roughly now, certainly probably in early 20noughties or the late 1990s. They have the traditional form of a stack and an engine house, which may have been used also for dewatering a mine if there was a mine down here as well, and also for haulage if it was actually a shaft that was bringing stuff up. They've all got kaolinite in them, obviously, but Wheal Grey and Tressails also have a number of other things, cassiterite and quartz and topaz. And quartz variety jasper, it's a microcrystalline form of jasper. Jasper is a minor microcrystalline form of quartz, which is usually brown or red, but I haven't got a picture of it. The only picture I've been able to find is this one, which again is from Mindat, and it's cassiterite is the very dark stuff. Quartz is the most of the matrix over here, and some of this white stuff is topaz, but it is very small. I've got a picture of one later, but that's very small as well, so we'll see that later. To the southwest of St Ives, there are a number of two areas, in fact, with a variety of names, and they're shown on here. There's a thin strip of water there, which is a Pendleith mine or Portia, and this hole here is Bedlam Green or Baker's Pit, two names. And the thing that stands out here is Castle Endiness Granite Quarry, which is still happily churning out granite for aggregate, roadstone, and anything else you want to put coarse granite in. There are remains of Pendleith here and Baker's Green here. This one you can't see much else in the photograph, but this the caption said that this was part of the drying house, because obviously when the china clay comes out of the mine, it's pretty wet and has to be purified to some extent and then dried before it's a nice powder that can actually be bagged up and sent off to wherever it's going. There are the usual minerals as we are starting to see them now. Baker's Pit does have some schorl and quartz, but I haven't managed to find a picture of that. Pennance, there's some debate over this as far as I'm concerned. It's mentioned as being a place that has kaolinite, and when you look at the minerals, then it is there, but this area here is very close to the Camborne Redruth area, which is much more well noted for its copper and tin mines. So I'm not totally sure that this actually was a china clay pit, but it may actually just have been a copper and or tin mine, because bornite's a copper sulfide and cassiterite's the oxide, chalcopyrite's a iron copper sulfide. So that it may not be a tin mine, but it could a kaolinite source, but was there. Belowda Beacon is just to the northwest of the St Austell granite, which we'll come back to later. And this is Belowda Beacon, or the top of it. It's a hump that you can actually see from the A30. And this is where the clay works used to be. It seems to be now a site for either caravans or cabins. By the time you wind the magnification up, you lose the detail to actually tell what these little things are on the end of the little roads. Again, cassiterite, topaz, and kaolinite. And I found a specimen of this, which is quite an interesting one, as from a geological point of view. Here's the cassiterite, no doubt with some topaz in there as well. But this is the country rock into which this cassiterite was emplaced as a vein. And it's this that is part of the metamorphic aureole, because these were Devonian sediments at one stage, but they've now been metamorphosed into something really hard, which they're generally called killers in that part of the world, sort of hardened country rocks. As I say, we'll come back to St Austell later. If we move on to Bodmin Moor, there are quite a number of places on Bodmin Moor where clay has been extracted. And having a quick look at the roadmap of the area, the stars where these particular places are, we'll start in the north, and then there are a few just north of the A30 going across diagonally, and then a number just south, and then a few scattered around the southern periphery of Bodmin Moor. This is what Stannon looks like now. It's a large hole in the ground. This is probably, well, this is a picture taken from the east. Whether it's actually taken from Round Willies or Rough Tor, I don't know. It's difficult to judge from the view. Hawks Tor, now anybody who's been down to Cornwall on the A30, because this is the eastbound carriageway, we're on the west, look across towards the northwest, and you can see this green hummock and remains of white stuff here. Again, when I went down to this part of the world in the 1950s on family holidays, this was all bright white, and this was an active china clay pit at the time, and it's obviously grassed over between now and 2016 when I incorporated this image from Google. Amazing what you can see on Street View if you choose to look. A little bit further southwest, got a few more holes in the ground either side of the A30 Temple or Greenbarrow here and Gunheath. Glyn Valley images still look somewhat like a minor clay pit. There's obviously some form of hole here with the spoil tips white from their mica and quartz and bits of kaolinite that they haven't been extracted, and the chimney, and no doubt all the works associated with purifying and drying the china clay are there as well. Gazelands and Parsons Park, they're just holes in the ground with water in. And the only last one is one of note. These are the remains of Carclete. And interesting here is that the stack is a square one, which is unusual for Cornwall. It's even got a bit of decoration on it. So, and these are the remains of the works. So if we have a look at the minerals, there aren't an enormous number to see from samples that I've been able to find and photograph. There's a little bit of amethyst, which is the purple form of quartz at Hawks Tor, just north of the A30. And then at Gazeland, which is the one down here, there's a little bit of wolframite as well. We'll come to that a bit later. So that's a tungsten ore. Hingston Down, which is halfway between Bodmin Moor and Dartmoor. It's a site of a well-known quarry that has produced an enormous number of minerals over the years. But as far as I'm aware, whilst it's mentioned as being a source of china clay, it doesn't really figure in my mind as a china clay extraction place. But I thought I would just include a still from a YouTube video of an explosion where they're actually blasting out some of the new rock for the bench. And as I say, this has been a site of an amazing number of minerals over the years, and that's talk in itself. So if we move on to Dartmoor, then again, most of the activity as far as Dartmoor is concerned is down here in the southwest corner. And there are a number of different sites. Most of the china clay now is being extracted from this area here, and we'll have a look at each of those in a moment. And then there's an old site out more in the middle of the moor, this little lake here, Red Lake. And I'll mention Drakelands in the mine in a moment. So these look more like what one might think a china clay pit should look like. Lee Moor, thanks to BGS, and Sean Lake, which I think this is still the largest of the lot. This is an excavation that may well be deeper now. I don't know. I've not seen any photographs more recent. Again, these two, White Helio and Collet Town. Again, this one looks like a big trench in the ground. Whether it's gone deeper or wider, I don't know. Likewise for this one. Filled with traditional bluish water from suspension of fluids, no doubt. And then Eden Moor looks like another fairly large operation. And this is what's left of the Red Lake, traditional conical pile with some water and some remains of some buildings. Lee Moor is the only one that's really produced a range of different minerals, cassiterite, some opal, we'll see that later, tourmaline again, and torbanite, which is a copper uranium phosphate. There's a little bit of radioactivity here, and all the others are largely just known for their Luxulyanite. Mentioned Drakelands mine when we start to talk about minerals. This is a tungsten exploration. Whoops, sorry about that. This is the tungsten exploration, and it's been in and out of the news with respect to how well it's doing. But this is a picture taken by one of our Belgian friends, Richard Denol, of a blade of wolframite, which is a mixed iron manganese tungstate. And it's turning out that it's a bit awkward to separate this from the other iron-containing minerals in this hole in the ground. And I think that's probably the reason why it hasn't realised its potential yet. Lee Moor, cassiterite can take an interesting form. This is also cassiterite. One gets used to seeing very dark brown or almost black, shiny crystals, but this is what's known as wood tin for obvious visual reasons. Where it's a very fibrous form of tin which forms these spherules, and these are actually quite heavy. Cassiterite is quite a heavy mineral. Tin being one of the later elements in the periodic table. And there's a little bit of quartz. In this case, the surface layers have been a little bit included, a little bit of hematite, one of the iron oxides. Rust to other people. And then go back to the St. Austell granite. This is where all the action is, and it really does look a mess on Google Earth. Holes all over the ground. Luxulyan, which we mentioned before, is out here. This is St. Austell and Charlestown, the harbour, although quite a lot of it was exported from Parr and also from Foy, elsewhere on the coast. So we'll have a look at some of these holes in the ground and what they contain. And it's perhaps easier to see them on this sort of map, which was produced by Stefan Weiss in the 1990s in the UK Journal of Mines and Minerals. The working pits at that time are, as it says, are stippled. The abandoned ones are striated, and then there are those which are flooded. Just small here and there. And this is Trevisco, mentioned very early on, was one that Carthew and Wedgwood were extracting their material from. But first of all, have a quick look at Bodelva, pardon. Most of you might know what goes on here now, and if you look from Google Earth again, you'll see exactly what's taken the place of the China clay pit. It's the Eden project. And I hadn't looked at it before putting this together from the air, and it's actually quite impressive from the air, but it's even more impressive from the ground, of course. It was on my last visit about 4 or 5 years ago, and the biomes are shining white and lots of trees now. First time I went, all of this was bare ground and they were just getting their act together. It was quite a marked change there. And there really are some amazing views in here of both the inside of the biomes and also the vegetation that they contain. Right, so we'll start on the west and go vaguely across to the east, and then we'll finish on Gunheath pit. This is from Melbur pit on the far west. These are called pig's eggs. A pretty obscure reason, I never did find out why, but what they are kaolinite and cerussite, which is a form of mica, pseudomorphs after the feldspar. So it's a form of alteration that hasn't lost the crystal form of the original orthoclase. This one at the bottom is definitely a Carlsbad twin. I'm not so sure about this one. My knowledge of twinning, there's something else called a Boveno twin, and it may be one of those. Carlsbads are much more common than some of the other pseudomorphs or some of the other forms of orthoclase, habits of orthoclase. And these occur in quite a number of different places across the St. Austell granite and elsewhere. This is topaz. Now you can see the whole crystal is only 1.5 millimeters long. So, and as far as I'm aware, this is quite a good picture. And I can explain later how this was taken if you want to. It's a technique that's becoming more and more common with certainly interested amateur mineralogists who've got sort of a little bit of photographic nous. And quartz, and this is Trelavour pit, a little bit further south. And you can see the quartz takes on some quite fantastic forms occasionally, and jumble of crystals. Tourmaline, as I said earlier, comes in a whole number of different subtypes. This is tourmaline is a family, so there are a number of family members. This is rossmanite, which is a lithium aluminium aluminosilicate with some boron in, and that's this sort of greenish colour. Again, this is one of the lithium minerals that's possibly being sought out for decomposing into lithium ions and hence onto lithium batteries. This is biotite. So it's a much darker colour in terms of usually brown or sometimes almost through black. Again, it's not a lithium one, but it's got some potassium in this time, and iron and manganese, magnesium rather. And this is probably biotite, and sitting on top of it is a little apatite crystal, which is a copper phosphate with fluorine, chlorine, or hydroxide. This is so small, it's only 2 millimeters across, and it's not been analysed, but it's more likely the fluorapatite rather than the chlorapatite or the hydroxide, merely because of where it came from, and the fact that there is some fluorination of granite. Fluorite itself does occur. It's a rather nice crystal from Wheal Prosper in St Denis. It's purple, reddish quartz, fluorite on opaque quartz, milky quartz. Quite a nice size specimen, really. And there's some opal there. This is not precious opal that you get from various other parts of the world, in particular Australia. But it has its own charm. This is largely brown and comes from West Carclay's pit. Quite a large lump there. This is also apatite, but it's the hexagonal habit of apatite in rather larger crystals. And on here, the blue, and it's on orthoclase, which is this lemony yellow. Yeah. We've seen this before from the Goonbarrow pit. The reason for showing it now is that all of this brown stuff over here is actually the remains of a cassiterite and tourmaline vein. So quite a lot of this black stuff is actually cassiterite. And when I collected this specimen, that's what it looked like. So you can see it's just been taken straight out of the rusty looking rock. Cassiterite are sort of the larger crystals, as we'll see in a moment. There is some topaz in the ground, and also the whole thing is very quartz rich. And then it's been coated with brown rust, which is probably ferric oxides, hydroxides with some water. But you can get rid of the rust chemically. A whole variety of different conditions for doing that. Again, I'll mention those later if anybody really wants to know. These are the cassiterite crystals, all the black stuff. There's some quartz here. And the ground mass in here also contains the topaz. I must confess, I was at a stage in 1985 when I collected this that I didn't really know much about mineralogy, so it didn't occur to me that there might be topaz down there. I could see the quartz and the cassiterite. And occasionally there are still some copper minerals. This is copper phosphate called the Batholith. And again, it's a very small crystal, but I assume that it's almost perfect unless there's some damage on the other side. It's a little bit out of focus for me, but there you go. Another pig's egg, this time from Bodelva, and this is the Eden project pit. So we've got a variety of interpenetrating orthoclase crystals which have been replaced by kaolinite and sericite. And then we come on to Gunheath pit. The reason for leaving this last is that it does have a really quite remarkable list of minerals. We won't see all of them, but have been found there over the years, and I'll explain why some of them are quite important. But it's quite common across. I had great difficulty finding a decent picture of this, and this is not a very good one, I'm afraid, but there's a variety of quartz called smoky quartz, and in this part of the world, smoky quartz gets much darker than you get in Scotland for the cairngorm, and it's these black crystals which are still quartz, but they've got minor impurities which, because there's some radioactivity in the rocks over the years, that causes changes inside the chemistry which give rise to almost total absorption of light, and so they appear black, even though they've got sort of nice shiny surfaces. Some more opal, and there are a few hints of little, whether this is diffraction or interference due to a slice of opal, or whether it's a hint of fire that you might get in an opal from Australia. I doubt it's the latter. It's probably a flake where you're getting interference figures. It might be to do with oil on water, but it's quite a nice specimen, and it was collected in 1970s by a guy called Arthur Scoble, although it belongs to this guy Ian Jones at the moment. One of the bits that I picked up in Gunheath have these little black, almost black fluorite crystals on that again, it's not a particularly brilliant picture. I think I could do better now, but you can see it's got a variety of extra faces on the corners. So it's not a cube, it's a cube with the corners cut, with all corners cut off. And hence it's more complicated looking from its reflections point of view. And this is one reason why Gunheath's become quite important. It's been known for quite some time that there was a turquoise vein in Gunheath, and you get this sort of light blue turquoise. There are occasional patches of really small microcrystals, but I haven't found a decent picture of those yet. And the white stuff is quartz, so it's quartz for turquoise vein. And it's a copper aluminium phosphate. And this area of the quarry was actually very rich in phosphates. And because of the rest of the chemistry of the China clay pit, they come in a variety of shapes and sizes and colours. So this is a mineral called Coccoxonite. That's the orange balls. So it's an aluminium iron phosphate. Quite a lot of phosphates, 17 in this particular formula, and a ridiculous number of waters, or approximate waters. The green stuff is again turquoise, but it's an iron-rich version called Rashleite. But that's not an official name, and Rashley was an important mineral collector and mine owner in the 1700s. So that's this green stuff here. And where they're fractured, you can see they're, again, radiating balls of fibrous needles that form these little hemispheres as far as we can see here. And this is a specimen I collected without really, I acquired this from somebody when I knew not very much about this area. And there are at least 4 different phosphates on here. The black things, or very dark green, there's dufranite, which is calcium iron phosphate. Leucophosphate here, which as its name suggests, has not got much colour, and that's a potassium iron phosphate. Chalcosiderite, which we've seen before, which is this green one. And then these little yellow blobs, which is called cerullivite, which is a sodium iron phosphate. And I got this one because I didn't know much about what I'd got, but I knew I'd got something yellow like this. And we'll come back to that in a moment. The leucophosphite does occur in a slightly better crystalline form, and it has these little hedgehogs of crystals. And it's a reasonable sized hand specimen, so it's quite rich in leucophosphite. Chalcosiderite, there are really some quite nice specimens. Again, this is not a small specimen. It's what I suppose some people would call a thumbnail, less than an inch long. But, and these lovely green mounds on a particularly striking on this rusty oxide coated background. And then here's some leucophosphite in about some chalcosiderite in a better crystalline form, and some more well-defined yellow blobs, which are these cerullivite crystals. Now, the reason why I've been sort of rabbiting on about cerullivite is that this was one that I found in the 1980s. And as soon as it was seen, somebody said, well, that's worth looking at, because they hadn't seen one before. So I sent it off to the Natural History Museum, and it came back as cerullivite. And it turned out that it was actually the first occurrence of cerullivite in the UK, which is always worth noting so that other people can have a specimen that's been analysed to actually go and refer to. And this is the same specimen taken by David Green, a friend of mine. And so you can still see the octahedral form with it. Now you see the colours of the green chalcosiderite and the yellow cerullivite. And the matrix here is quartz. There are much better pictures now of cerullivite, and this is one by a guy in Germany, and these are really nice spherical aggregates of cerullivite crystals. Okay, that's where I'm going to stop now, although there are a whole host of references that you can look up and websites, and these were the people who did the analysis at the Natural History Museum, Chris Stanley and Peter Tandy. Mike Rumsey's the current curator of minerals, and he's the guy who will actually look at stuff that you send him to. I've done most of this exploration with members of the Russell Society, particularly the trips to Cornwall, and also lots of interesting discussions with people from the Micromap Society, particularly with respect to taking photographs of these things, very small things.
Wow, Frank, that was amazing. You know, I thought geology was complex enough because of different rocks or mixtures of rocks over and the influence of time. But then when you take it down to the molecular level, there's a whole new world, isn't there? I mean, in fact, I was brought up on quite simple chemical formula, and your formula are amazing.
Yeah, well, I mean, chemistry formulas like these have been known for, well, centuries. Some of the early chemists from Sweden and France were analysing things that were still complicated in their day and still complicated in our day as well.
Yes, but you know, you explain the logic of them, which is, you know, it's always a bit of a mystery. Sometimes you look at those formula and you think, well, what does that mean? And you, you know, usefully unpick some of them, which was very useful to me. Thank you once again, Frank, for your talk. And I wondered whether we could show our appreciation in the usual way.
Yeah, thank you. It was a pleasure.
It's always nice to do it in a room, but you know, you know, it's good to say thank you in that way. Well, thank you much, everybody, for coming back to us this evening, and I look forward to meeting you again in October.